I'll do another router at the bottom. And then I'll also do another link over here towards my DMZ. And put one router over here. This is going to be router 2. F0/0. This is going to be gig 0/0 of my firewall, gig 0/2 of the firewall, and we'll keep this as gig 0/1 of the firewall. Router 3 over here, router 1 over here, F0/0. And F0/0 over here. And this guy over here is my ASA1. Good so far? At the same time, my network addresses 10.11.11.0/24. This is going to be my inside network. That's what I'm planning on doing. Oops. I need to put it a little higher. This on the outside is going to be, let's say, a public address of 20.0. And this guy over here is going to be, let's say, a private address on the DMZ of 192.168 network. And I will say this is my DMZ network. I'll make this bigger, like that. Everybody okay with this? This is called the logical diagram, which shows you the layer 3 topology. Everybody good with this? This is what I want to create. All good? Okay. Now, but the thing about these routers and the firewall is physically they're connected differently. Physically, if I had to go to my physical diagram, I need to find out where my physical topology is. Let's check over here, maybe in my classes. Let me check if I have the physical topology over here. Yeah, there you go. This is my physical topology over here. What do I mean by physical topology? This is how the wires are done in my rack. So router 1, F00 is connected to switch 1, port 1, 2, F00 is connected to switch 2, port 2, so on and so forth. My ASA physical topology is like that. I'm just using ASA1 right now. So 00 is connected to switch 2, port 11, 01 is connected to port 11 on switch 1, 2 is on 12 on switch 1, 3 is on 12 on switch 2. Switch 1 on the left, switch 2 on the right. Everybody understand that. And the two switches are trunked to each other. If you take a look at the bottom over here, based on port 21 and 22. I want to make sure you guys understand that. This is how the physical wiring is done. What my objective is to take the physical diagram and create this logical diagram out of it. Good so far? You guys understand what my objective is? Everybody on the same page. So my objective is to create this logical topology from that physical diagram. Yeses, please. And then I'll go ahead and show you how to do that. Okay. So the way I do that is in these particular steps. So I'll write them down for you guys. So this falls under this thing called the physical to logical mapping. Taking a physical topology and creating a logical map from it. How do I do it? Step 1. connect or configure the trunks between the switches. Just follow these steps and you will be able to do the physical to logical diagram. Configure the trunks between the switches. And if you look at your physical diagram, what ports are those? Ports 21, 22, 21, 22. So I'll go into my rack onto switch 1. This is switch 1 over here. It's a blank switch right now. I'll go to switch 2. It's a blank switch. These are physical devices. I'll just call it switch 1. I'll type this in because I'm going to be doing this on all the routers as well. I'll just use a different scratch pad for myself. No IP domain dash lookup, line con 0, log sync, host R or whatever I want to use as the host name. So I'll copy it and keep on pasting it onto the different devices. On the wrong device, okay, right over here. Host is going to be switch 1. Oh, I already have switch 1 as a host. Good. So first thing, as I said, is the trunk. I'll find out my ports. 2122 is a trunk port, so it's gig 20/ whatever. So 20/21, 20/22 are my trunks. So interface range, gig 20/21 through 22, switch port trunk, in cap .1q, normal trunking, switch port mode trunk. On switch 2, I'll do the same thing. Again, copy this thing over here. This is switch 2. Check my interfaces. They're based on, I believe, 50/ whatever. So interface range 50F 5/0/21 and 22. Switch port trunk in cap .1q, switch port mode trunk. So that's my first step. Everybody okay with that? So switch port show interface trunk should tell me that I am trunking on those 2 ports. That's my first step in terms of doing a logical to physical mapping. So I'll write that down for you guys. So on switch 1, interface range gig 20/21. This is on my rack. It might be different for different racks. In cap .1q, switch port mode trunk. Done. Step 2, configure the VLANs. I would say configure VTP with switch 1 as the server. So I don't need to create the VLANs everywhere. Create the VLANs that are required. So I would go on to switch 1, make it into my VTP server. So I'll say VTP domain, let's say Cisco, VTP mode, which is server by default, but I'll put it in anyways. VTP password just to secure it a bit. Cisco 123, that should be good enough. This is on switch 1, and then I'll do the same thing on switch 2. The difference is I'm going to make it into a client. You guys, everybody okay with VTP, the purpose of VTP? You guys understand what VTP does? It allows us the ability to create the VLANs on one switch and they get propagated to all the switches. So I'll create the VLANs on my VTP server. So copy it over there on switch 1 and create the VLAN. So if I'm done it okay, I should see the VLANs 10, 20, and 30 created over here. Okay. Similarly, on the second switch, I'm going to make it into a client. Client gets all its VLANs created by the server. So I'll copy it. Go to switch 2, which is my client. And I will paste it so my VLANs should be created. So VLAN, there you go. VLANs 10, 20, and 30 are there as well. So basically what you have is you have the VLANs propagated from the VTP server to the VTP client. That part is done for you guys. Everybody okay with that? Any questions about this before I move forward to the next step? Good, everybody? Give me the yes and we'll move forward. All right, now, in terms of our topology that I want to create over here, I want to put, I'll set this up as VLAN 20. Oops. We'll set this as VLAN 10. And we'll set this one as VLAN 30. The 3 VLANs that I had created for each site. So what do I have in VLAN? Let's start with 10, one VLAN at a time. What ports do I have in VLAN 10? Help me out. Router 1? Is there? Shouldn't be. Speed should be good over here. The video is lagging? Okay, I'll just go slow on the video then. So in terms of what port 10 right now? R1 F00 and ASA gig 01 should be in VLAN 10. Everybody agree with that? You guys okay with this? Yeah? Now, step 3. Assign the ports to the appropriate VLANs. Do this one VLAN at a time. So I picked on VLAN 10. So VLAN 10, there are 2 ports, R1F00 and ASA gig 01. R1F00, gig 1 of ASA 1. So I'll go to my physical topology. All right. On my physical topology, I'll try to locate where these 2 devices are at. Where are the 2 devices? Where's gig 01 of ASA 1 and R1F00? Which ports? Take a look at the physical topology. It's telling you that. Help me out. Come on. Switch 1, gig 01 is R1 and ASA 1 is gig 011. So 1 and 11 should be in VLAN 10. Agreed? And that's how you do the physical to logical mapping. That's pretty much it. So I'll go to switch 1. Based on what you guys told me, I'll say interface range gig 20/1 and 20/11. Switch port host, which is a macro for switch port access VLAN, let's say 10, switch port mode access, and also doing spanning tree port fast. There's a macro for doing the same thing that's called switch port host. So this host, switch port host, does mode access and spanning tree port fast for you. So I don't need to worry about doing that. It's a built-in macro that you have in the switches. All right, so I'll write that down for you guys. So VLAN 10, we figured out was switch 1, interface range, gig 2/0/1, and gig 2/0/11. You could just do switch port host switch port, access, VLAN 10. Everybody good with this? Yes? All right, so VLAN 20 now. Coming back to the diagram again, go to the logical diagram. It says R2, F00, and ASA1, 00 should be in VLAN 20. So these two ports, now that I know that it's at R2F00 and gig00 of ASA1, I need to go to my physical topology, find out where the ports are connected to, what switch ports, and then assign them to the appropriate VLAN. So we'll do that on the other topology, other diagram. That's a physical diagram. So you guys tell me, what ports should I put into VLAN 20? R2F00 and ASA1 gig00. Which two ports is it? Where's R2F00 connected to? Switch 1 gig1/02 and ASA1 gig00. Where's that connected to? Switch 2 port 11. So those two ports should be in the same VLAN. So let's go ahead and do that part. I'll write it for you in Notepad because then I would need to copy it anyways. So we agreed on switch 1. So gig 2/0/2, switch port host, switch port access VLAN 20 and switch 2. This one has the port as fast Ethernet 5/0/11. That's what I need to do. So let's do that over here. Copy it. Switch 1. Done. Let's go to switch 2. Copy the config for switch 2. This way your notes are also done. Those two ports are on the same VLAN as well. What's the only thing left over now? So I've done the outside, I've done the inside. Now the DMZ. What are the two ports in the DMZ? Help me out with this, guys. Gig02 of ASA and R3F00 should be in the same VLAN. So now go to your physical topology. R3F00 is port 3 on switch 1, and gig02 on ASA1 is on port 12. So 3 and 12 should be in the same VLAN. You guys agree? VLAN 30. Okay, so let's do that then. Again, I'm going to do it in Notepad because it's going to cut down on me typing it again for the notes portion. This is both on switch 1. So I'll just say interface range gig 2/0/3, gig 2/0/12. Right? I'll just make sure. 02 is on 12, yeah. Switch port host. Go to switch 1, paste it, should be done. So show VLAN, and you should see those ports being assigned. 1 and 11, port 2 of the particular switch in VLAN 20, the other one is on switch 2, and then 3 and 12 on the same VLAN. So this is how you do it in terms of physical to logical, and I'm done actually. So at this point, I can save my switch config because these are live devices, and I can actually get rid of this. I really don't care about the physical topology now because everything now is set up as if it's like this, as if the logical connections are R1 to go out needs to go through the ASA to get to R2. Now you can just dump the physical topology because you're done with it. Everybody okay with this? Understand? So I'm going to use this as my baseline network. So once this is done, now I can go ahead and start configuring the devices. We'll start with R1. F00 should be 10.11.11, let's say dot. I'll put the IPs over here so you guys can see it as well. I'll put this as .1 on this network. Which network is this? 10.11.11.0 network. We'll put the ASA as .10 on this network. That's gig 01. This one, again, I'm going to put .10 as my network. This one again as .10 as my network. Okay. This one is going to be .2 on the 192.1.20 network, and this guy is going to be .3 on this network. That's my objective. I'm not going to run any routing because I want to run the routing protocols as my first step. And because I want to do routing, I'm going to simulate some loopback networks over here. I'm going to put this as my loopback network over here. I'll put an address to it. Let's say loopback 0, 10.1.1.0/24. Similarly, I'll do another one over here. Loopback 0, say 10.3.3.0. Come on. There you go. And I'll create a couple of loopbacks over here as well. I'm going to be using this loopback later on, so I'm going to create 2 of them. Simulating the internet. R2 is my edge router towards the internet. So think about this being the internet. I'll call this loopback 199. And the address is 199.1.1.0, some network on the internet. Okay, and I'm going to create a similar one over here. Loopback 200, 200.1.1.0, network on the internet. So these 2 loopbacks are going to simulate as if they're connected to the R2 is connected to the internet. These are some public addresses on the internet. Everybody okay with this diagram over here? Let me save this diagram as well. Save as, and I shall save it on your D drive, annual package, CCIE security, this bootcamp, ASA1. I don't think I have any other ASA diagrams. So this is going to be my topology. All right, so let's go ahead and start configuring it. Basic configuration of the routers. Router 1 with the loopback and a physical interface. The ASA with 3 interfaces. R3 with the loopback and a physical interface. R2 with a physical interface and 2 loopbacks. Let's configure the routers first. Start with router 1. While it's coming up, I'll do the no. Start with router 1 on the inside. I have that thingy over here. Copy. And I'll paste it. So I'm going to be configuring the first router that's on the inside. This is your loopback over here. All right, I'm not going to do a default gateway right now because I want to run routing over here. On router 2 on the outside, I'll copy this. This is R2. If you guys have any questions, please feel free to ask. Just basic routing config right now. I should have done this in Notepad because I want to write this for your notes as well. Show IP interface brief. You can do that with the third one. But in the meantime, I will write the notes for you guys. This is your basic configuration of the network. Start with R1. I did interface F0/0, IP address 10.11.11.1, interface loopback 0, router 2, we created loopback 199. All right, and R3. What did I say the network was? I'll just match that over here. 1.10. Let's go down over here. Yep, sorry. Thank you, Renton. And then I'll also copy the other stuff. Down over here, host R3. Should be able to ping. Oh, actually, I won't be able to ping because I haven't configured the ASA. Let's do that in Notepad as well, because that's another thing that I want your notes to have. ASA1, interface gig 0/0, name if, outside. I don't need to set the security level, but I'll do it anyways. Loopback, security level 0. IP address is 20.10, no shut. Interface gig 0/1. Name if is inside. No shut. Again, I'll set the security level just in case. And the third interface over here is gig 0/2. Let's put it as 50. Copy it. And let's go to ASA1. It's a blank ASA right now. Host name, let's say, is ASA1. And I'll paste it. Now, if everything is hunky-dory, I should be able to ping my directly connected routers. Yep, I am. That's okay, because I have it copied. Thank you. Host name. So now I should be able to ping 192.1.20.2. should we be able to ping 11.1 and 192.168.1.3. So all my directly connected interfaces are communicating. Everybody okay with this? You guys understand what I did? So I created a logical and a physical, created a logical topology from a physical topology. I initialized my ASA based on what we had done the last time around. Good. Now, this is our objective for today. We're going to start with routing, run the routing protocols, do the NAT, ACLs, access policies, very simple, and then do the transparent firewall as well today. Okie doke. So with that in mind, the first thing is routing. My objective over here is to run routing between the different interfaces that I have over here. So what I'm going to do over here, just so that I knock out all three in one shot, I'm on different sides of the interfaces. I'm going to run OSPF over here on the outside towards R2. I'm going to run, let's say, EIGRP on the inside between ASA and this segment. And I want to run RIP on this side towards R3. Everybody good with that? Once I'm done with the basic configuration of OSPF, EIGRP, and RIP on the ASA, it's essentially the same way you do it on the routers. You need to do the same thing on the ASA. I'm going to do the authentication of the three protocols. So that's something that you need to be aware of. That's something that they ask on a regular basis, is the authentication of the routing protocols. Good so far? You guys understand that? Generally on the exam, they would have configured your routing on the routers. You would need to do the routing on the firewall portion, but it's not that different. It's pretty much the same. Understand the concept now. You understand what I'm planning on doing. Any questions about that? I want to knock out all the three protocols at the same time. Everybody okay, guys? Good so far? All right, so let's do it. Let's start with the EIGRP on the inside. So again, EIGRP as a protocol. This is the protocol I'm going to be running between R1 and the ASA. So on R1, router, let's say EIGRP 100, no auto summary. Network 192.168. No, sorry, 10.11.11.0. On router 1, I'll just do 10.0.0.0 because it'll take care of my 10 network on the inside as well. On the ASA, I'll be a little bit more specific. And I want you guys to see this over here. My network statement in or on your ASA, I don't use the wildcard mask, I use the normal mask. I'm enabling EIGRP on the 10.11.11.0 network. All right, 255.255.255.0. I had to do the same thing on the router. Let's just do it on the router so you guys can see the difference. If you want to be more specific, you would have to do it like that, using the inverse mask. On the firewall, you don't have a concept of the inverse mask, it's all the normal mask. That's how you would run EIGRP on the ASA versus running it on the firewall, on the router. Pretty much the same. The only difference is the mask. Other than that, it's exactly the same way. You guys see that? So let's do the ASA first. Knock that out. Once the ASA is done, I'll go to the router and paste config as well. I have that 10.1 loopback network that I'm advertising in EIGRP. My neighbor relationship should come up. There you go. So show IP EIGRP neighbor should show me the 10.11.11.10 as my neighbor. I go on to the ASA. and do show route, command is show route rather than show IP route over here, you should see one route learned via EIGRP, which is 10110. That's a loop back behind R1. Questions, guys? You guys are okay with this? Basic routing that I'm doing over here. Good, everybody. Everybody, yeses, please, before I do the authentication part over here. All right, let's do the authentication of EIGRP. So not only do I want to run routing, I want to make sure I'm talking to a validated peer. The way I'm going to do that is by using a key and a key ID. How do I do that? It's a little different on the router versus the firewall, so I'm going to do it on the router first. In EIGRP, the only type of authentication it supports over here is MD5. But the way you do that on the router is by using this concept of a keychain. Keychain is a key holder. Give it a name, it doesn't matter, it's locally significant, whatever you want to call it, ABC. Inside the keychain, you have a key ID. Important. You need to match it on the other side. Let's say key 1. Inside the key 1, you have a key string, which is the actual password. These two things are the ones that are actually sent across to the other side. All right? So key 1, key string, Cisco 123. Everybody okay with this? Once I create it, I will apply it to my interface. How do I apply it to my interface? Go to the F00 interface on R1, IP authentication. Mode for EIGRP 100 is MD5. So basically what I'm saying is I'm turning on authentication on the interface based on MD5 for EIGRP autonomous system number 100. Once I turn it on based on MD5, the next thing I need to do is apply the keychain. How do I apply the keychain? Key dash chain for EIGRP 100 is ABC. And when I apply the keychain, essentially I'm applying the key ID and the key string to that interface. That means any neighbor on this interface needs to have that key string and that key ID. That needs to match. ABC is just a way to place it and connect it up to the interface. ABC is locally significant. You don't have a concept of ABC actually on the firewall. So even between two routers, if you're doing it, the keychain concept, the keychain name is locally significant. Good so far? You guys understand how to do it on the router side. As soon as I copy and paste this onto my router, my neighbor relationship will go down. Questions,